Namaste students, this is Dr. Prachi Fartiyal from Department of Mathematics, Omkaranand Government Degree College, Deepprayag. In this lecture, we will discuss finitely generated space, dimensions and rank of matrix. So firstly, we will start from finitely generated space. Now, what do you mean by finitely generated space? Now let us suppose we are having a vector space VF. Then this vector space VF is said to be finitely generated of finite dimension space if there exists a finite subset S of V such that LS equals to V. Now it means that if we are having a vector space VF, then if we are having a subset S, if this subset S is finite, then it means it is a finitely generated space. So we can write the definition like this: a vector space VF is said to be finitely generated, and sometimes we call it finite dimension space also, or finite dimensional space if there exists a finite subset S of V such that LS is equals to V. Now this we have talked about finitely generated space or finite dimension space. Now the next topic is dimension of a vector space. What do you mean by dimension of a vector space? Students, if we are having any vector space, and in this vector space we are having a basis set, then the number of elements in any basis set is known as the dimension. Now let us suppose we are having a basis set A1, A2, then its dimension will be 2. If we are having A1, A2, A3, 3 elements, then its dimension will be 3. So if we are having A1, A2, An, then our dimension will be n. Now for this one, if you want to write down the definition, then we can say it is the number of elements of vectors in any basis set. Now about the rank. What do you mean by the rank? Now let us suppose we are having a matrix A. Let A be any M cross N matrix defined over field F. Or we can say field K. Now we are having two things. One is the row space and one is the column space. Now what do you mean by the row space? Row space of any matrix A is the subspace of k raised to power m generated by the row vectors of A. Now we can say row space of any matrix A is the subspace of k raised to power m generated by row vectors of A. Now what do you mean by the column space? Similarly, if we are saying the column of A is the subspace of k raised to power n generated by column vectors of A. Now this dimension of row space is row rank, and dimension of column space is column rank. The common value of row rank and column rank is called rank. Rank is common value of row rank and column rank. Thank you.